Day 6, physics, graphing, and here we will be doing linear graphs, but the overall goal with any graph is to find the mathematical relationship between the two quantities that you're graphing. In math, we generically call those two quantities x and y, but in physics there'll be actual quantities like force and distance, or velocity and time. But let's start off with a generic, simple, straightforward linear graph given here. The linear graphs are the easiest to do by hand. The other graphs, quadratics, cubics, inverse square graphs, are kind of difficult to do by hand, so we will be using the calculator for those. And in fact, we'll be using the calculator even for lines eventually, but I want you to be able to do linear graphing by hand. The most generic statement for a line is this y equals mx plus b. You probably remember that from freshman year or whenever you had Algebra 1. As you could recall, m stands for slope, and b is the y-intercept. So those two quantities we'll be trying to figure out numerically. We want to find the slope, like 6, and there would be units. In this case, we're ignoring the units. And the y-intercept, like 5 or -5 or 12. We want to find numerical values for the slope and the y-intercept. So I have an example here already graphed, and we want to try to find the slope and the y-intercept for this graph in the form of y equals mx plus b. So you graph this, which is already done, and you will draw your line of best fit. So let me try that. So you would draw this line, and I drew it longer than it needed to be. Generally, longer is better. I used a ruler. You can sketch it in your notes, but use a ruler if you have one, or a straight edge. So there's the line of best fit. Once you've drawn your line of best fit as best you can, you essentially ignore your data points. It's kind of like they don't exist anymore. What exists now is the line, and we want to find the slope and the y-intercept of this line. Working backwards here, actually the y-intercept is the easier thing to determine. You just look at that. It's right down here. It looks like it's positive 1. I could even say 1.0 because I have enough resolution there to see that it's not halfway between 1 and 2, it's not a quarter of the way, or so forth. I can make a good estimate. I can go to 2 sig figs on that. So I can say that b equals 1.0. And I could include units. Here there are no units. You don't need to use units on these graphs, at least for now. Now, the thing that's a little bit harder is the slope. If you recall, however, from algebra, slope, the definition of slope, is this. M equals, or slope equals, rise over run. Now mathematically, that would go like this. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You don't need to write this down every time. Let me go back here for a second. This is an important number. I'm going to circle that. This equation that I'm looking at right here is the concept or mathematical expression for, or equation for, finding the slope of a line. We're going to do this by hand right now. So what you'll want to do, or what I like to do, or what I want you to do, is to make a triangle with your line. And you can make a big triangle. You don't need to use the entire line. Here it's technically a line segment. But for example, if I take any 2 random spots here, let me try to pick this spot right here and say this spot right here. Once again, I'm staying away from data points. You can use data points if they're on the line, and you could use the y-intercept point as one of your points. But I'm picking 2 points to show you can use any 2 points. Try to pick 2 points, those 2 blue dots that are far apart. And then what you do is you sketch in, and once again, using a straight edge would be better. I'm not going to use a straight edge right now, but if I just come straight across here and form a triangle. So this is supposed to be vertical. So I have a right angle right here. Those two blue legs form a triangle with that hypotenuse, which is the line. So here's my hypotenuse. So I have this triangle right here. All right. This leg right here is the rise. And this leg on the bottom is the run. It's the horizontal. So bottom line is, if you want to, there's different ways to look at this, but if you look at those two blue points that I have on the graph, what I want you to do is to draw this triangle when you do the problems. Optional, or let's say it's not optional. I want you to label your 2 points here. It's not optional. This point up here, you do the best you can to label that spot, and looks like it's about 5.5. If you look on the scale down here, it's at about 5.5 over, and it's vertical. I picked it out so it was like 17, and you could say 17.0, but well, let's say it's 17.0. If you just said 17, that would be okay. And this bottom point down here on the left, the other point that I highlighted is, let's see here, it's right about here, it's about 0.3. It's about 0.3. So you're reading this off the graph. The best you can do is 1 sig fig on that. And it was at 2.0 in height, or the y value. So bottom line is, it doesn't really matter which one you pick as your y sub 1 and y sub 2. But I'm going to pick this as my second value, my x sub 2. This will be my x sub 2 right here. I can label that if you want to see that. You don't need to do this every time. That's x sub 2, y sub 2. Down over here on the left, this is x sub 1, y sub 1. So, recap, what I want you to do is to draw with a ruler your best fit line. So you'll be drawing this line. Draw this triangle. Label the 2 points right here and here. And then show me this calculation, which is this. In this case, the slope, m, is y sub 2, which I have up there as 17.0, minus y sub 1, which is 2.0, divided by x sub 2, which is 5.5, minus x sub 1, which is 0.3. So the slope here comes out to be 15.0 divided by 5.2. And we have a 3 sig fig number divided by a 2 sig fig number, so that's going to give you a 2 sig fig answer. So my slope here comes out to be m equals 2.9. We don't need to use units yet. They didn't give us any units. That's my slope. So now I have m. That's an important number. Circle that. All right, so the final answer here, and I'll do this in blue on the bottom here, will be like this. Here's what I want to see as the final answer. That is y equals mx, so it's 2.9x plus b plus 1.0. That's the mathematical relationship between x and y. So now I can pick any x and plug in and figure out what the value for y is for any given x in that relationship. So let's summarize a little bit. When you do these problems, the key thing that I want to see is your labeled points on the diagram. So you're going to have this point labeled and this point labeled. I'd like to see the triangle. This calculation right here, this grouping right here, is probably the most important thing of all. Your calculation of the slope. So this, that is consistent with your labeled points on the diagram and your final answer. So what you do not need to do on the homework is this. I don't need to see that. You don't even need to put this down because it's just an observation. You put that in the answer. But I want you to be consistent with the sig figs. Bottom line here is the best you can do really from reading this graph is 2 sig figs, and my answer is consistent with that, so circle your answer. So the most important thing I'm looking for is this grouping and this, and then your diagram. Let's practice a couple more. Here is an example where we'll need to graph it first, draw our line of best fit, and then find the equation. Hopefully it's a line. I believe this one will be a line. We'll find out here in a second. Sometimes you can't tell, and that's where the calculator will be very handy in the future. But for now, let's graph it and see what happens. So my rules for graphing are you need to label your axes. Typically, this is not a hard and fast rule, but typically the first column is usually what we call the independent variable. We'll talk more about that. These are the ones that you determined. But these typically, this column will typically go on the x-axis, this axis right here. So you got to come up with a good scale and you have to label this. Now, the highest number there is 8. I think what will work well is if we go every 2 tick marks, like if we make this tick mark right here 1.0. Actually, you don't need to say 0.0. You could just say, because it'll be inherent in the problem, that's 1, 2, 3, 4. So I'm going every other tick mark, 5, 6, 7, 8, and you can go beyond that, 9 and 10. But this is the scale for time. So what you need to write down, this is for any lab, you write down that that's the quantity of time, and then the units in parentheses in seconds. So I've scaled this, and I've labeled this. Now the vertical axis is speed, and it goes to 155, so we got to figure out, should we go by tens? 10, 20, 30, 40, 50, 60, 70. Yeah, let's go by tens, but I'm going to label every other one, every other tick mark. That's 20, and then 40, that's a 40, 60, 80, this marker is a little thick, but I think you get the idea. 100, 120, 140, 160, and so on, 180, and 200. Okay, and it's labeled that's speed in meters per second. You don't need to label the overall graph, but this is a speed versus time graph. So that's what I expect you to do when you do graphs in this class, is to label the axes. And you can plot your points. I'm going to pause and do that. You can pause the video and do that yourself. So I've graphed the points. I like to use little plus symbols because they're easier to see as you move forward. You can make dots if you wish, but you'll also have that option on your calculators to make it a little bit bigger so you can see that. And most of the time you're going to be using plus symbols or little boxes or little circles instead of dots. They're hard to see. And now I'm going to draw my line of best fit. So I used a straight edge to do the best I could to draw my line of best fit. Once again, you may need to pause your video to do this. And I can see that my y-intercept is going to be down here in the negative territory. So I will need to extend as best I can, and it's hard for me to use a ruler for that, so I'm just going to kind of extend this as best I can. I'll go back a little bit here. This line comes straight down. That's my y-axis, so to speak. And I have to get a ruler out, or you could get a ruler out and scale this, but I have to go into the negative territory because this value right here is 0. In this corner right here, that's 0. And I have to go down to my y-intercept, and if I kind of mark this off, that's negative 20, negative 30, negative 40, negative 50-ish. So you can put numbers on that. Negative 20, that's a negative 20, negative 40, and then negative 50. And once again, there's going to be some leeway here because I'm now sort of doing freehand with a ruler. It's a little bit better. it looks like my y-intercept down there is about negative, say, 52. So B is roughly, and sometimes it's indicated like this. You don't need to do this squiggly roughly, but it's roughly negative 52 meters per second. Once again, you don't need to use the units, but that's what the units would be for the speed. Negative 52 meters per second. I will put the units on there, but it's not necessary for this class for now in the equation. But now we have to find the slope. So I'm going to mark off two sort of random spots. I will do that. Let's use blue. I'm going to use, well, I'm going to use this spot right here. That's a pretty easy one to use. And this spot, say, I don't know, right about there. Okay? And you don't have to draw the triangle, the rise and the run, but I do want you to label these points. Certainly label these points. So I'm showing you what, at minimum, what you need to do. So this up here is my y sub x sub 2 and x sub 1. So that's roughly 9.0, because I picked an intersection there. 9.0 is my x coordinate there, and 180. 180. All right, and then down here on the lower left, my x sub 1 and x sub 2, this point down here, it's about 2.3. You might say 2.4. And you might have picked two different points, so you might have different numbers than I have. You don't have to use my points. You probably will in the notes here, but there's going to be some variation on here. As long as you pick 2 points that are far away from each other, this will work. You'll get the same answer, at least a close answer. You'll see that in a minute here. But the x-coordinate there is 2.4, and that's 0 for the y-coordinate, because I picked an easy one there. So now, here's the calculation I want to see, and that's the calculation of the slope. M equals y sub 2, which is the 180, minus y sub 1, which is the 0, divided by x sub 2, which is the 9.0, that's is 2 sig figs, minus 2.4, so we get M equals 180 over 6.6. So we will get a 2 sig fig number when we divide that. And I get M equals 27. All right, the units will be, once again, you don't need to use them, and they're going to be a little fancy here. They're actually meters per second squared, which we will talk about later. I'm going to ignore that for a few minutes here because I want you to get the numerical values here for now. We'll talk about the units later. But that's an important number there, the slope, M equals 27, and the y-intercept, B equals negative 52. And now we're ready to write our answer. So I'm looking for the answer. The answer to this problem that I'm looking for is then y equals mx, so 27x, plus b, but actually here it's minus 52. And that would be your answer. Y equals 27x minus 52. But if you want to be a little bit more professional about this, you would say something like this. Speed, or velocity, I'm going to use a v for velocity. We'll talk about that later on as well. V equals 27t minus 52. You don't need to do this, but I'm just showing you what's coming in the future to emphasize that we have a velocity or a speed and a time. The velocity is equal to 27, and it's meters per second squared would be the units, but 27 times t times the time minus 52. So now using this equation, if I plug in any time, any value for the time, it could tell you the speed or the velocity at that time. Technically the speed. I don't like using S for speed because it looks like a 5. We'll come back to that. So this tells you the speed at any given time, t. So once again, you graph it, you label your axes, you draw your data and your line of best fit, you label your 2 points, and you do the calculation. Show me the slope calculation. This is the most important math to show me. the math you're using for your 2 points that you picked, you can actually skip this step right here. But I put it in. So you need to have this step, the answer, and then actually the final answer for the relationship between x and y, or v and t, or speed and time. And that is finding the equation of a linear graph by hand. We'll practice some more in class.